I guess I wanted to start each class with, does anyone have any questions about the upcoming exam, study guide? How to prepare? My plan is to write the exam today, so I'll be able to answer more questions about the length of the exam, stuff like that. Number of points and out of extra credit after I decide it this afternoon. I am a fan of extra credit. So last time we started talking about different code smells. We talked about everything in the bloat category. So we're going to move on from that, but I just wanted to give a very quick overview of the bloat that we talked about. So we talked about long methods and breaking up methods into smaller pieces that are more easily digestible. We talked about large classes and the fact that this can just evolve over time to the point where they need to be split up into smaller classes. Using too many primitives for things that are actually constructs, even if those constructs are very small, like currency or ranges or phone numbers, it can still be very beneficial to make them an object so that they can be expanded upon later or forced into a certain format, or you can have different optional formats for things like phone numbers. You could write a method like isLegal phone number that looks for parentheses around the first 3 digits, or looks for the different kinds of styles that you might expect, an optional dash in there. So you can match any potential number to, is this a phone number, yes or no? You would not be able to do that if you stored it as just an integer. We talked about long parameter lists. If you have a bunch of parameters, you can often pass an entire object, or if separate objects, if they're coming together from separate objects, you can make a class out of all of that and then instantiate and pass an object of that class. And finally, we talked about data clumps. So this is identical groups of variables. The example that we used was connecting to a database. If you always need the same few pieces of information in order to connect to a database, then you could make a class with that information, instantiate an object of that information, and use that object to connect to the database rather than hunting for every single time where are each of those pieces of data. Now we're going to go into OO abuse. So alternative classes with different interfaces. This is a mouthful, but you can think that you have 2 separate classes that perform the same task, but have different method names for that same task. So 2 different objects doing the same thing and calling them different things in those different classes. What would be an example of that? I guess we can start there. Come up with a theoretical example of some generic classes, like a person class, and describe the 2 classes, describe what you might call the different methods that might be able to be combined that do the same thing. Where might you see that?
Apples and oranges class.
Sure.
They have color.
It'd be a field. What kind of behavior could we have?
Is it edible?
Is what?
Is it edible?
Is edible. So just like the logic for determining that. But so maybe one of them is a fruit, and we have a fruit class, and maybe there are some subclasses to that. And maybe we have a vegetable class, and one of them is, I don't know, consume, and one of them is eat. Called 2 separate things that do the same thing in different classes that have the exact same functionality despite the fact that they're different objects. So things you can do about this, you can rename methods to make them identical. This is very useful in an API. You can imagine something like if you yourself as a programmer import a library, and that library has some different things in it. Maybe one of them is a scanner and one of them is a file reader or a buffered reader. These are all similar kinds of objects, right? Have we seen any of these kinds of objects before? So if a scanner does something like you're looking for the next string, use the next method. If you have a buffered reader, what if that said next string or called it next string instead of next? It would be nice if there was a standard if different objects within the same library with the same functionality had the same method named. And that way you wouldn't need to look up the API for how to get a hold of the next string for these different kinds of objects. They should have the same name so that you should be able to guess what the associated method is called and the associated parameters for that method. If you're doing this yourself, you can also move around the methods, adding parameters so that wherever in one class, if it takes 2 parameters, in another class it takes 1 parameter, even if one of those parameters isn't particularly used or useful, if it's the same functionality or close to the same functionality, then they should take the same parameter list so that it looks the same from the end user's perspective. If part of it is duplicated, you can turn this into an inheritance hierarchy. You extract a superclass out of it, and then you can unify these 2 methods in a superclass. And any differences between them would then be redefined in the subclasses. You may find that after doing this associated fix, oh my gosh, the classes are identical. They have exactly the same fields and exactly the same methods. You may discover that one of them can be deleted. As in many of these, there are some situations where you may not want to do this. In this case, it can be really difficult to do for not a huge gain. It could be a lot of work, and if at the end of that you're modifying one thing just to make sure that it's consistent, it may be pointless. So use critical thinking, as always in this class, to figure out, is it worth going through this process? Yes or no? You don't necessarily want to combine classes in different libraries, each that has their own version of the class. Because if you import one of those libraries, you would expect that functionality to be there. So if you delete it from one library and then someone imports it and suddenly can't use that functionality, that's bad. So it's okay for classes to be identical as long as they live in different libraries. Do we know what we mean by different libraries when I say that? Yeah.
They're completely 2 different areas, so if you make a command, then it's not going to try to guess which one to go call, because it's like, I only have access to this one, so I'm only gonna look at this one.
Yeah, so an example for this would be the 2 different kinds of lists that we've talked about, the array list and the linked list. Both of those are going to potentially have maybe some subclass or some submethod that does exactly the same thing in exactly the same way. If I'm solving a problem, I'm either going to import the array list or the linked list. I'm not going to import both. Or if I do import both, it's okay for there to be 2 different versions of the same thing, one for the array list and one for the linked list. If you import one, it should have that functionality. If you import both, it's okay to be able to call the same functionality on either object. You don't necessarily need to merge them, because that would force users to import both the linked list and the array list if they just wanted to do something for one of the 2, which is not ideal. In fact, that's really bad. Questions on this? To go back to that point of libraries, the library would be the support for a particular object or a particular idea. So something like a library for all linked list features. So refused bequest is the next OO abuse. So in this case, we have some subclass somewhere only using some of its methods or properties that are inherited from its parents. So if you're going to create an inheritance hierarchy, then you need to, everything you inherit from your parents should be used. If you have unneeded methods that are unused, maybe throwing exceptions, that could be bad. You can critically think about this when you're looking at a superclass and a subclass, and you say, this just feels like these should be separate objects. These aren't actually related. When I instantiate the subclass, it's not using anything from its parent class. I can't instantiate anything from its parent class, so maybe this shouldn't be an inheritance hierarchy. So if the inheritance makes absolutely no sense, we're going to replace it with this concept called delegation, where instead of solving the problem in the superclass, we're going to kind of pass the problem along to the other object that says, here's what we need to get done. You do this. I'm not going to support that because it's not part of my task. It's not part of what's useful to the object that I am. You delegate it to the object for whom they should be handling it. Think of it like each object should have a specialization. Just like your career, you're going to have a specialization. If you end up being a software engineer, you should not have to, for instance, do IT's job and fix a machine when a network outage happens or when there's a security vulnerability. That's not your job. You delegate it to the person who is the expert in that field. Just like in your classes, each one of your classes should have some very specific purpose of something that it's really good at. And if it's trying to do something that's outside of that scope, it should delegate it to some other object. If inheritance is appropriate and still makes sense here, then you can extract all of these used fields and methods, putting them in a brand new superclass. And then you add that to the inheritance hierarchy, and that will factor out the code duplication. So some images here to help with this concept. Here we have this really strange hierarchy where we have a superclass legs and subclass animal and chair. Animal legs are very different from chair legs. So maybe it doesn't necessarily make sense for this to be a hierarchy. Because maybe in the superclass for legs, we try to factor out everything that animal legs and chair legs share in common. How much do they share in common? Not very much, right? If anything at all. So why is this inheritance hierarchy existing at all if when we talk about a chair's legs, we don't use anything from the superclass? So instead, here's another example of what you might do. We have a vector made up of a stack, and now we can say instead of inheriting it, we can compose a stack as part of a vector. And we're actually going to talk about, this is some UML language, unified modeling language. We're actually going to take a break from stuff we're going to do and talk about what these different symbols mean and how to read diagrams like this. I don't want to go too deep into it until we actually do that process, but we can come back and look at this slide afterwards. But so here's the issue. You can see that we now have a superclass for animal legs, and now the chair legs doesn't make sense to be a subclass of the animal legs. So we can break that out into its own class. Or if there were more of these, we could break out a new superclass and break this off, such that this wasn't part of this inheritance hierarchy, it's part of a new inheritance hierarchy for furniture legs, for instance. We had animal legs and furniture legs, which are distinct from each other. They're their own separate hierarchies. Does that make sense? All right, switch statements. These are actually terrible in OO languages. They're perfectly fine in procedural languages, but in OO concepts, switches are generally bad form. So this can be considered overuse of if statements or very large switch statements. They were useful back in the 60s and 70s before OO really took off and became the main way that we program. So their legacy embedded in a lot of the languages that we use, but there are better ways in an object-oriented paradigm to represent this concept of choosing between many options. So we have polymorphism. Anytime that you are about to make a really long switch statement, you should think, how can I factor this into polymorphism? And a lot of times when it takes, it takes more space to talk about an idea on a slide, I just have a link to Refactoring Guru. And so I'm gonna click on this, and so I can show you what Refactoring Guru looks like. And of course I can't do that because I switched this back to extending. There's Refactoring Guru. So whenever you're having some part of the refactoring course portion of Refactoring Guru, it's going to give you a problem and an associated solution and a code example for this, which is extremely useful. I don't think that I could do better than this in my own slides, and it would take a lot of finagling to come up with a nice visual display for this in a way that they've already done. So if you're studying future slides and you see a link to this, know that there's missing information that should be on the slide that's embedded in this site. So the problem states you have a conditional that performs various actions depending on an object type or properties. The solution is to create subclasses matching the branches of that conditional. So you have some kind of superclass and a bunch of subclasses that where you have, switch on A, B, C, D, E. You have subclasses for A and B and C and D and E, and a superclass kind of representing the choice. So if we had, in this code example, we have the bird class, and we have a switch on the type of the bird. So it can either be a European bird or an African bird or a Norwegian blue bird. And then there's get base speed that has to be done for each one of these. And notice that this is significantly more code, but at the same time, it's very extendable and it's very usable in terms of.
It's a Monty Python joke. We just got it.
Yeah, yes, it is. Computer scientists are actually very funny and very dry funny usually, but yeah. So being able to do this, now we have a bird and we have a class for each subtype of bird. And this means that we get a lot more functionality than we can in a switch case. And it means that we can abstract everything into the base class here, the superclass for all birds. We know in order to be a bird, we need to be able to get the speed. And in order to have a subclass of this, this will just tell us which type it is. So we can instantiate any of these subtypes as the supertype if we need to with polymorphism, kind of as we talked about in our review. And again, it is more code, but it gives us a lot more flexibility and a lot more options. And this is why we don't extend. All right. So we'll see this a lot. We'll see some links to Refactoring Guru wherever there is a good code example or a good way to explain what's going on here. So you extract the if, long if, or the switch case, moving it to a single new class or a bunch of subclasses in an inheritance hierarchy that allow us to use polymorphism. So why does this lead to better code? There's a principle in OO design that says, tell, don't ask. An object, rather than asking an object about its state, hey, are you a Norwegian blue? Are you a European? Are you a, instead of asking them that question, let them tell you what type they are. You tell the object what it needs to do. I need you to tell me your speed. And the object will figure out how to get that for you. It's embedded in the object, not in the logic of the switch case statement. And this can help you with identical conditionals across multiple switch statements in different classes. Maybe you need to figure out what type of bird it is. You're going to need a switch case in every single one of those, trying to identify which bird it is. And now, if it's in an inheritance hierarchy, the object tells you, I'm a European bird. I'm an African bird. And you can see how that can be useful in removing excess code, especially as this blows up and you need to refer to the same thing from multiple places. Extension now, if we're going to come up with a new type of bird. Let's say we're going to come up with a new type of bird. It is a North American bird. Instead of having to go do something like, oh my gosh, where are all my switch cases that try to identify where birds are throughout all of my code? I now need to add an extra case to every single one of those switch statements. Now you just make a new class, a new subclass, and it will automatically, when you ask this bird, how do I get your speed? It will automatically determine which type it is and go do the appropriate logic. Which means that refactoring and doing things like extending your code, this is when I talk about extending your code, this is a lot of what I mean. You're making a new object of the same type. You don't have to go hunt through your code for everywhere you reference it. If you miss it somewhere, your program is suddenly going to crash for some reason saying, I don't know what bird type this is. There's no case for this thing that you're telling me to do. Questions about the last one? Questions about switch statements? Everything we need to know about refactoring them into polymorphism rather than using switch? All right, we'll go through one more and then we'll take a break and do something slightly funny. All right, so the issue of temporary fields, they're going to get their values and are needed by their objects only under certain circumstances. So if you've ever designed an object where you have a field that is kind of an optional field, it may get initialized to the empty string or empty or nothing until it's needed, and it's only needed sometimes. This is bad. So outside of those circumstances, it's just this empty placeholder variable for some circumstance that you may never run into. So when an algorithm or class requires a bunch of parameters, we already talked about too many parameters, but if it requires many parameters, some of those parameters might be optional or unused or only used in certain situations. So you replace the parameters with fields to store that data because the parameters are optional. So now the fields are optional, and that fixes the long parameter list issue, but doesn't fix you're creating a variable here for no reason most of the time. So only used when the algorithm is being run, otherwise there's nothing there. Things you can do about this: if you have the temporary field and any method that use them, you can extract them into their own object. And that way that field always has a value when that class is instantiated, and you're only going to instantiate that object when you're ready to run the algorithm. This helps code clarity. If you are looking at a class like this that has one of these extra fields, you might ask yourself, what is the purpose of this field, and not really be able to come up with an answer. If you extract that into a class that is instantiated only when this algorithm is going to be run, then the field only exists when it has a purpose. Questions about temporary fields? I know, thrilling stuff. All right, I am really quickly going to find this. So we talked about testing. A lot of the jobs for testing, it's often, if your company is big enough, a separate position. But we can phrase this like a typical someone walks into a bar kind of joke, where a software tester walks into a bar, runs into a bar, crawls into a bar, dances into a bar, flies into a bar, jumps into a bar, and then orders a beer, 2 beers, 0 beers, 99,999,999 beers, a lizard in a beer glass, -1 beer, QWERTY wop beers. It's pretty good, but you can imagine the tests that are necessary to assume that this whole process works. You have to start thinking about the corner cases, the edge cases, the cases that you don't actually think about if you're operating a bar. So this is relevant to the testing that we talked about and things that you may never see, but in a program, something like this would actually be a reasonable thing to test to make sure that you don't enter a failure state under any circumstance. And now just next time you walk into a bar, do one of these things. I think it's pretty funny. All right, that was our quick 2-minute aside. All right, next one. Alternative classes with different interfaces. So we have 2 different classes. They do exactly the same thing, but have different method names. This is awful. This is probably my least favorite OO abuse to actually see. And you see it a lot of times out there when you have lots of different engineers working on the same project. If this is the case, then person 1 recognizes that the stuff that I need to implement requires this particular prior code in order to be able for it to work. Person number 2, also working on a completely different part of the project, needs the exact same stuff in order to make their code work. So without talking to each other, they each implement the prerequisites that they need in their own separate classes and then use that to interface with their own code. And if you zoom out beyond just whatever coder 1 is focused on and coder 2 is focused on and start to look at the project in the big picture, these 2 classes are both created and they do the same thing. So they should not both exist. Was there a question or comment?
Yeah, I think this is the first slide we've been on to.
Did we? Yeah. My memory is wonderful.
It's impressive how different it was the second time.
Yeah.
Totally improv. It's awesome.
That's kind of just how I lecture. I don't prep for this. I just deliver it off the top of my head.
I was like, this sounds different. Looks the same.
Yeah. So we did switch statements, we did temporary fields. Change preventers. So that's all the OO abuse we're gonna go over. We're gonna talk about some change preventers next. So divergent change is this concept of having a bunch of unrelated methods when you make a particular change to a class. Does that make sense? This example might clear things up. So you're a store and you have classes for every different product type that you have. Maybe some of them get ordered and some of them is how do you fulfill this order when this object is part of the order? You need to make changes to the methods for locating the object in the warehouse, displaying it, ordering products, something along those lines. And we're just adding a new product type. So there are a bunch of unrelated methods that you need to change in order to interface this with all of the rest of your logic, with all of the rest of your code. So things you can do, if there are different behaviors of classes, you can extract them into their own class. And that way you can utilize just the appropriate classes for a particular object or a particular new, that makes making a new object or a new product much easier because you just select the appropriate behaviors for how to handle that. And if you need to add new behaviors, then it becomes easy to do that as well. If different classes end up having the same behavior or close to the same behavior, you can combine them into an inheritance hierarchy. Some benefits from this is you get improved code organization, which is great. Reduced code duplication. Since you're combining classes into their own separate, into their individual class, stuff might have been duplicated in those two classes, so you merge it together and get a much better outcome. You know that once you finish a product, you have to support it. So imagine that you've created the next great software of some kind for someone. Once you finish that and they discover a bug, you're responsible for fixing that bug. If they discover something that has gone wrong, it's not necessarily a bug, but it's some either unintended feature or something that they said they wanted implemented that did not end up getting implemented. Maybe you gave them an alpha version of the code to start with, and you need to continue to support to push it out. They have issues, they're talking about their experience with the code. You need to map what they're doing with the internals of your code. So where in the code is the behavior scripted that they are experiencing? And the less code duplication you have and the more organized your code, it's so much easier to be able to do that mapping. They have an issue, you know right where to look. You don't have to spend a ton of time trying to figure that out. So that is divergent change. Questions about divergent change? Here's a fun name. Shotgun surgery. So this is the exact opposite to divergent change. So these are very linked together. So that was about making many different changes into a single class. This is a single change that has to be made to multiple different classes. And so that's why it's kind of like shotgun surgery. You're like, we need to make a change to this, but it's a simple change, but it is a simple change that needs to be made to a bunch of different classes. Any modification you make, small changes to a bunch of different classes. And that single responsibility of change this is split up amongst the different classes and can be the result of if you overzealously apply divergent change and split that out into different classes, then when you make those small changes, you may end up needing to make changes to a bunch of different classes. So the difference between divergent change and shotgun surgery, where you should think about being, is somewhere in the middle. These kind of, they describe the two different extremes that you can be in. And both of those extremes are usually very bad. It's better to be somewhere in the middle. So fixes for this. If you have existing class behaviors in different classes, you can consolidate those into a single class. If that class doesn't exist, you may need to create it. If you move code like this, you may find that some of your classes don't do very much anymore, or don't do anything at all. If you notice a class doesn't do anything, you should delete it. If you have classes that rely on this behavior, then you may need to think about where in your code is this reliance, and make sure that if class A relies on class B, and class B is being deleted and replaced with class C, you need to redirect that contingency from class A to class B to class A to class C. And we're going to talk about this when we talk about couplers, where classes are interrelated and dependent on each other, to try to remove that so that you don't have to do any of this arrow switching and thinking about that in more detail than you want to. Some of the design patterns we're discussing will actually help you identify an appropriate middle ground between these extremes, which is nice. So applying some design patterns will help with this. We will see some additional, we'll cycle back to this concept later in this quarter so that we can see some tools to help us make this decision, because the decision is pretty arbitrary. Benefits, we get better organization, less code duplication, easier maintenance. We're going to see these concepts throughout all of it. A lot of it is better organization. A lot of these help with less code duplication. A lot of this helps with easier maintenance of your code when things change. That is the overall goal of any code design, is to make sure that you adhere to that as much as possible. Parallel inheritance hierarchies. This one's particularly fun. So you create a new subclass for a superclass, And then you need to make another subclass for another class and another inheritance hierarchy. So you have two inheritance hierarchies that are kind of interrelated. If you make a subclass for one, you need to make a subclass for another. Does that concept make sense? So that's an issue. So if you have instances of one hierarchy composed of the other, I'll have an image for this in a second. And that will help. So one hierarchy gets removed in the referred class, which is useful. I swear I have an image for this. There we go. So here's the problem, right? We have separate inheritance hierarchies. When we add one to one, we add one to the other. So if you make instances of one hierarchy composed of the other, so now instead of having these two separate hierarchies, this class has a component of it, a field or a method that represents this, everything embedded in this. So one of the fields of this is this object. One of the fields of this is this object. One of the fields of this is this object. And now when you create this, all you have to do is make sure that when you construct this object, it's instead of being in this hierarchy, it's a field of this object. Does that make sense?
Do you think you could think of an example?
So parallel inheritance hierarchies, where are we going to see something like that? I know there are plenty of examples of it. Can I come up with one off the top of my head? I'll come back to this with a good example. I can think of a couple bad examples that I don't really want to use, but I'll come up with a good example and we can talk about this at the start of tomorrow's class. It doesn't particularly matter what the example is necessarily if the idea is clear, like you have a particular structure and there's interdependence on that structure. Where maybe we have one set of behaviors and another set of behaviors that represent the same object. I'll come up with a good example. I recognize that's abstract. Other questions about this? All right, those are the last of the change preventers that keep us from being able to change our code. Dispensables are going to be things that we can just kind of get rid of. So for comments, the big issue with comments is your code requires a bunch of explanation in the middle of it in order to understand what's going on. Bad fix to this is just deleting the comments. You don't want to make your code less clear by removing it. You want to refactor this into something that's going to make more sense. So comments are very much like deodorant, they mask poorly worded code. So rather than refactoring, rather than just deleting your comments, you want to make sure that your comments are clear and or they're factored into a Java doc, or your code itself is more explanatory. So the best comments are code. If you name your variables in a descriptive form, if you name your methods something specific and descriptive, everything you need to know about the code should be embedded in the code or in a brief Java doc comment. You do not want inline comments for the most part at all in your code. If you need to explain something like a complex expression. So in your code, you have an expression that is just really long and convoluted, made up of a bunch of parts that all reference different pieces of your code. You can split them up into different sub-expressions so that you have, like, for instance, we can use a very basic example of this. So you have something like terrible variable names, I will be the first person to admit. This is just to be able to see it, so we have something like some int result equals a times b plus c. Not really the most complicated expression, but it can be broken down, right? We could break this into components where we have I don't even know, I want to come up with a good variable name here so that this doesn't look terrible. But the idea is whatever this is called is just the a times b. And then we'll reference this in the sub-expression. Let's call this part 1 for now. That's a terrible idea. If this were actual code, I would be the first person to say, this is bad, don't do this. And you can't use a variable called final, that's a. But you can break this down into parts that it's easier to digest, which is useful. And again, it's not the best example of this because it's not particularly legible, but if we applied this to some kind of actual problem, there'd be something to name this for what these sub-expressions represent. And then it's very easy to digest. And you can imagine that if this wasn't just 3 things, this was 10 things, and each of them was a logical, some kind of Boolean expression where you had. Have you seen this before where your code wraps around? It's so long that can all be split up logically into subcomponents, and that will make things easier to read and not require a long comment explaining the entire logic that you went through. So benefits from this, code becomes more intuitive and obvious, which is always a good thing. You may need some inline comments if you're explaining the reason something is implemented the way it is. You will often find in coding that you have different ways to implement something. So for instance, why did you pick a linked list over an array list? I love the list examples because they're so relevant to so many different things, but the reasoning behind why you chose one thing over another thing, or the reason this database connection is done in this particular way. There are lots of ways you could do it. You need some way of explaining why did you implement it this way? That's good for an inline comment because it doesn't go in the Java doc because it doesn't explain what the method does. And the Java doc comment should explain this connects you to a database, or this does something, constructs a list and does something to it. There's still the reasoning behind why you chose those tools. Duplicate code. You look at 2 code fragments and they are suspiciously identical. This happens way more than you would expect. I see it all the time in introductory courses and even in upper division courses. When people just want to make something work, it's very easy to create 2 different code fragments that look very similar. So another way you can do this is if you have a bunch of different programmers working on different pieces of code that have identical or nearly identical solutions, they will all implement it slightly differently. And they're all working at the same time, so they can't see that someone else already implemented it. And so we have a bunch of similar looking code. This duplication may not be obvious or apparent. Deadlines exist. Just like for labs as a student, they will have deadlines to produce something in industry, and that can make you create a quick fix that is something that works for now, and you fully recognize, I'm gonna need to come back to this and make these changes later. How frequently do you actually do that? How frequently do you go back to code that works and go refactor it to make it nicer, easier, cleaner? If it works, it works. The next deadline is coming up already. That needs some additional fixes. That's going to go to the top of your priority list. The fixing the stuff you just kind of hacked together to make it work for the last deadline, that is not going to be the top of your priority list. By the time you would get around to this, you've probably forgotten about it. So lots of potential fixes. But it depends on where the duplicate code is. We can look very quickly at what this might look like. I love the image. So some treatment. If the same code is found in 2 or more methods in the same class, we can extract the method and be able to combine them into a single method that utilizes the features of the first and the features of the second. You just kind of combine them and delete both of the originals, keeping both of the logic there. And remember, or note that each of these are links as well. If you don't know what they mean by extract method, you can click on extract method and it brings up, again, that problem and solution that allows you to get a code example and some whys and some benefits to these actual refactoring ideas. So I don't like to use these names too much in the slides, but if I refer to you to something like this, then they're going to give you some of these refactoring tools. So these links are very important for understanding how to actually code this as well. So the duplicate code is inside a constructor. You can use the concept of pull up constructor body, which means that some of what's done in the constructor's body is going to become part of the parameters so that you get the information that you need instead of going through it in the constructor. Duplicate code is similar but not completely identical. Form template method. And again, I'm gonna leave this for now for us to kind of go into in a bit more depth later as we have some time, but we are out of time. So I think tomorrow we're gonna come back to the question about today with an example of parallel inheritance hierarchies. And I also want people to get, just because it's the last day before an exam, I want people to get a little bit more programming experience. So I'm thinking we'll probably put a pause on this for now. I'm not too worried about the pace of the course yet. We'll see how that changes, but a little bit of hands-on coding wouldn't be a bad thing. So I'll see you all tomorrow for that.
Yeah.
I apologize for how dry this was.
Thank you.